So, what we want to do today, we need to talk about end behavior. We've talked about roots, x-intercepts, we've talked about multiplicity. Once we nail down this end behavior, then we'll start being able to graph some of these guys, okay? So if we look at this, let's look at this graph of the polynomial you see here. We know this function has zeros at x equal -2, -1, 0, 1, and 2, okay? Now, what are the factors of this polynomial? No, that's not a factor. That's not a factor. What are factors? What are they like? I mean, x minus 2 is one factor. X plus 2 is a factor. X plus 1. X minus 1. X minus 0. I can just write an x, okay? Those are all the factors of this polynomial. If these are all the roots, 1, 2, 3, 4, 5, these are all the factors, 1, 2, 3, 4, 5. Okay, I've got one corresponding to each of those, okay? Now, here's what I want you to do. I want you to look as the x values of this graph. As my x values go this way, where are the y values on that graph? So as the x values go to -infinity, where are the y values going? As you travel to the left, here's the graph. Here are the y values. As the x values go, they go where? Down to what number? -infinity. Okay, so when my x values go to the left, my y values are going to -infinity. When my x values go to the right, to positive infinity, where are my y values going? They're going to positive infinity, okay? So that's the end behavior of this graph. This graph is behaving like x cubed at the endpoints. It's going up over here and down over here. It's got other stuff happening in the middle that we can handle, but the end behavior is just like x cubed. Pardon me? Okay. So, what you need to know, and this is just, all of this flows from the degree and the leading coefficient, but if I look at it, if I have let's start with even degree. Even degree polynomials, okay, if they have a leading coefficient, they're going to look just like x squared. If they have a negative coefficient, what do you think they're going to look like? No. Like negative x. So even degree, these polynomials are either going to look like x squared or negative x squared. So if it's x, if I have a positive coefficient, it's going to go up at the ends. Negative coefficient is going to go down at the ends. Okay. If I have an odd degree polynomial, it's either going to look like x cubed or it's going to look like negative x cubed. An odd degree with a positive coefficient is going to look like x cubed. If there's a negative coefficient, it's going to look like negative x cubed. So those are parent functions that we've done. So in order to do this, let's look at the graph that we just did above. So look at the graph that we just did above. What do you think the degree of this polynomial is, even or odd? I mean, you can figure this one out, but just by looking at the graph. It's an odd. Even if I didn't have all this stuff, this would have to be an odd degree polynomial because it goes up on one end and down on the other, okay? So I know it's odd. The leading coefficient here, you think it's positive or negative? It's positive because it looks like x cubed. If it had a negative coefficient, it would look like negative x cubed. So I can look at that graph without knowing any of those roots and tell that that's an odd degree with a positive leading coefficient. So let's look at some graphs here. First of all, I want to know if the degree is even or odd and if the leading coefficient is positive or negative. So the degree of this one, is it even or odd? Nope. This is an even degree. Okay, even is like x squared. Okay, it goes up on both ends. It has to be an even degree. Now, I don't know if this is 4th degree, 6th degree, or 8th degree. I don't know, but I know the degree is even. The leading coefficient, is it positive or negative? Positive. It's positive because it goes up just like x squared does, okay? So if you're confused, you know x squared does this. It's even degree and positive goes up. Now what about this one? Is this even degree or odd degree? Yeah, this is an odd degree. the leading coefficient, is it positive or negative? It's negative, okay, because x cubed looks like this. Negative x cubed looks like this. So this looks more like negative x cubed. What about the next one here? Is it odd or even? Yeah, this is an odd degree. Leading coefficient is what? Positive, because it looks like x cubed. What about this one? Even or odd? It's an even degree because both sides go down, okay? Is the leading coefficient negative or positive? It is negative because it looks like negative x squared. This one, degree is odd or even? Odd. This is an odd degree. The leading coefficient, positive or negative? Positive. What about the next one? Even, positive. What about the next one? Odd, negative. And the next one, even, negative. Okay, so even degree polynomials are going to look like a touchdown or an upside down touchdown. Odd degree polynomials are going to look like x cubed, like this, or negative x cubed. So every polynomial, just by knowing its degree and leading coefficient, you can tell what that is. Now, here's the thing where we just have some mathematical terminology that don't let it get in the way of what your understanding is. But this is something, if you take a pre-calc or calculus class, you'll see. This is the way we describe the end behavior. One way of describing is it goes up over here and it goes up over here. But that's not a very mathematical way of saying it. What we're saying here is the limit as x approaches negative infinity of f of x. So this says, if you travel on the x-axis toward negative infinity, which direction is that? X-axis to negative infinity, which way am I going? Left. This is saying as you travel to the left, your y values are going where? Up. No. Your y values are either up or down. This says when your x values go to the left, your y values are going up. This says when your x values are going to the, which way is infinity? Right. When your x values are going to the right, your y values are going up. That's all that is saying. How would I say that the y values are going down? If the x values go to the left and the y values go down, what would this number be? Negative infinity. And same thing here. If the y values were going down, it would be negative infinity. Okay? So let's look at some examples just using that limit notation. One way that people can do this is look at it graphically. When I go to the left, where are my y values going? Are they going up or down? They're going down. So I know just by looking at the graph, when the x values go to the left, the y values are going down. What number represents I'm going down and I'm never coming back? Negative infinity. As the x values go to negative infinity, the y values are going negative infinity. Now, look in this direction. As the x values go to positive infinity, where are the y values going? They're going to positive infinity. Okay? So as the x values go to the right, the y values are going up. That's all this means. Okay? And notice we have an arrow here. We don't write equal. You don't say that this limit equals infinity because infinity is not a what? It is not a number, okay? It is a direction. You can't say something equals infinity because it's not a number. So, let's do some examples. First one, what is the degree of this polynomial? 25. Let's go with 4, okay? The highest degree term I see is 4, okay? What is the leading coefficient? 3. Now, what I'm really interested in, the degree of this thing, is that an even or odd degree? It is an even degree. And that leading coefficient, is it positive or negative? Positive. So, what does this graph look like by show of hands? It's going to look like this, okay? So I know this graph is going to go up over here and up over here. I don't know what it does in the middle, but I know it looks like this on the endpoints. So, as I travel x to the negative infinity, where are my y values going to go? Up. As I travel to the right, where are my y values going to go? Up. That's just what those arrows mean. So sometimes drawing the arrows helps. It's like doing the hands, okay? So what is the degree of this one? This is a 5th degree. What is the leading coefficient? Negative 2. So this is what kind of degree? Odd degree. What kind of leading coefficient? negative. So what does that one look like with your hands? It's going to be this one. This is x cubed. This is the negative x cubed. So it means this one's going to be going up over here, but down over here. Was there a question? Well, 5 is an odd number. 4 is an even number. Okay, so that's where we get that. So we know this function does what you see here with these arrows. So as my x values go to the left, where are my y values going? Infinity. As my x values go to the right, where are my y values going? Negative infinity, okay? So all we're doing here with this infinity and this limit notation is just a more mathematical way of saying it goes up on both ends, or it goes down, or it goes up or down. So if it helps you to draw these arrows or use your hands, that's fine. What is the degree of this guy? This is a 4th degree polynomial, okay? What's the leading coefficient? Yeah, leading coefficient is -2. So this is what degree, even or odd? Even degree. The leading coefficient, is it positive or negative? Negative. What does this one look like with your hands? Yeah, it's going to go down like an upside down touchdown. So if it helps to draw these arrows, that's what this graph has to look like. So as I travel to the left, what's the answer to this first one? Yeah, negative infinity. Both of these answers are negative infinity for this one, okay? What's the degree of the next one? 5. What is the leading coefficient? 2. So this is an odd degree with a positive leading coefficient. What does that one look like? What is odd with a positive coefficient going to look like? It's going to look like which function we know? X cubed, okay? So it means it's going to go down over here and up over here, okay? You've got a 1 times 1 times 1 times 2, okay? So it's a positive coefficient. Odd is going to look like x cubed. So what's the answer to these two questions? Yeah, negative infinity, positive infinity. What's the degree of the next one? Degree is 12, okay? What's the leading coefficient? 2. So this is an even degree with a positive coefficient. That looks like what? Touchdown, okay? So what are the answers to the two limit questions? Yeah, infinity, infinity, okay? So what we've done so far, you know how to find the roots or the zeros of a polynomial. You can look at that on a graph. You know how to tell when a root crosses, the graph crosses the axis. That means a multiplicity is an odd number. You know what it means when it touches the axis and does not cross. That multiplicity is what kind of number? An even number. You know how to find the degree, you know the leading coefficient, and we've now talked about what the end behavior is based on the degree and the leading coefficient. So this is a lot of stuff that you can now put together for the graph, okay? So we talked about odd degrees are either going to look like x cubed or negative x cubed. Even degrees are either going to look like x squared or negative x squared. Those are the only choices to what these polynomials are going to look like when you get to the end values, okay? So this is called end behavior of the polynomial. Now, if I use all that information, you should be surprised that you know a lot and you know how to graph this guy now, okay? What is the degree of this guy? 3. What is the leading coefficient? 1. So immediately, I know what the end behavior is. It's going to look like what? It's going to look like x cubed. So I know that it's going to go up in this direction and it's going to go down in this direction. Okay. There's going to be stuff happening in between that I haven't determined yet, but I know it goes up to the right and down to the left. Okay. So what is the answer to this? As my x values go to negative infinity, where are my y values going? Negative infinity. What's the answer to the next one? Positive infinity. Okay. So the arrows are just a graphical visualization of what is happening there. Now, what are the x-intercepts? So these are points. Yeah, the x-intercepts are going to be at 3, 0, negative 2, 0, and 1, 0. Now, are there any of these roots with multiplicity? Which one? Multiplicity would be something like this. If I saw a squared there, which I do not see, okay? So in this case, there are none, okay? So that means, what is my graph going to do at each of these locations? It's going to cross the axis, okay? So I typically, when I'm doing this up on the board, so I go 3, 0, 1, 2, 3. I'm drawing a green circle because I know I cross there. Negative 2, I'm going to cross. And at 1, I'm going to cross. These are the only 3 places this graph will ever do anything on the x-axis. And it crosses every time, okay? Now, the other point that I might need to help myself is the y-intercept. The y-intercept is what you get by setting what? X equal to what? If you set x equal to 0, you find the y-intercept. So let's set x equal to 0 in that equation, okay? So f of 0 is going to be negative 3 times 2 times negative 1. What's negative 3 times 2 times negative 1? 6, okay? So this tells me that the y-intercept is the point 0, 6. So if I go to 0, 6, that is right here, okay? So I now know 4 points on this graph. Now, where is this graph going to start? Is it going to start up here, or is it going to start down here? Yeah, it's going to start down here. I know that, okay? I know it has to look like x cubed. So here's what it has to do. It has to go up through this point. It has to hit this point. And what does it have to do here? It has to cross, but then it has to do what? It has to come back up and it has to end over here. That's all it can do. So that's all I'm going to do. I'm just going to connect the dots here. I know that this graph does something like this. And that's it. Now, is that a very accurate graph? No, okay? Because I don't know, at this point right here, did it really come down to here or did it come down to here? I don't know. I don't care. You can spend time if you want, but I don't really care. Did it go up to this point, or maybe it went up a little bit and then came down? I don't know. But here's all I know. You've got the end behavior correct. You have the correct behavior at every x-intercept, and you have the y-intercept. That is a wonderful approximation of what the graph of this polynomial looks like, okay? So this is why you can't memorize all of these like we did the parent functions, but it's why you have to synthesize a lot of things we put together to be able to graph this guy. So questions over that? Feel okay? Okay. Pardon me? Sure. Let's look at the, you want to do it on your own? Okay, let's talk through it. There is one I'll have you do on your own in a minute. First of all, what is the degree, and this is what it's going to look like on your test. What's the degree of this polynomial? 3. What is the leading coefficient? Leading coefficient is -1. Yeah, so you've got, what you've got out front, it looks like you've got a -1 out in front of everything. There's a 1 in front of that next x, a 1, and a 1. You multiply all those, you get -1. Now, this is an odd degree with a negative coefficient. What do I know at this point? It goes like this is x cubed, but what's my graph going to be doing? It's going to be this, okay? It's going to look like negative x cubed, so it's going to go up in this direction and down in this direction, okay? So what does it mean the answer to these two questions are here? Infinity and negative infinity. Now, what are the x-intercepts? Yeah, -4, 0. Yeah, -1, 0, and 1, 0. Okay. Is there any multiplicity here? No. My clue for multiplicity, I would see one of these things would be squared or cubed or to the 4th power, okay? I don't see that. So let's go ahead and graph these. So what happens at each of these points right here? I cross the axis. So at -4, at -1, and at +1, okay? The next thing is to find the y-intercept. You find the y-intercept by setting x equal to what? 0. Yeah, x equals 0. If I set x equal to 0 in that equation, I get -4 times 1 times -1. What is that number? 4. So my y-intercept is 0, 4. Okay. Now I know enough to graph this. Okay, where does this thing have to start? It has to start up here. And not just before I graph it, I'm saying, can it go through this point, hit that point, come down here, and end up in the bottom? Yes, that is all possible. So it's going to start in the top. It's going to do something like this. And that's what this graph does. Okay. Again, there's some accuracy that's missing here, but I don't care about that. You've got the end behavior correct, you've got the y and x intercepts all correct, and you've got the general shape of this graph. Now, the next one, I was going to let you do on your own, but it has the multiplicity, so let's just see about how we handle this one. What's the degree of this guy?
3.
Nope. This is 4th degree, okay? So it's real critical that you get to, like if you said it's 3rd degree, you're going to think exhibit behavior is one thing. So you got to get this right. This is a 4th degree polynomial. What's the leading coefficient? -1. So what's a 4th degree with a negative coefficient going to look like? It's going to go down on both ends. So I know it's going to look like this on the end point. So what are the answer to these two limit questions? Yeah. As I go to the left, I go to -infinity. As I go to the right, I go to -infinity. Okay. What are the x-intercepts? I like to do that before the y. What are the x-intercepts? 1, 0, -1, 0, and -2, 0. Now, is there multiplicity? Yes, there is a multiplicity of 2 at which point? At x equal 1 or at 1, 0. Okay. There's a multiplicity of 2 at x equal 1. Now, what does that mean happens at that point? It does not cross the axis. So now here's what I do when I go to graph these x-intercepts. So at 1, 0, I know that I do not cross the axis. So I'm going to put a red circle there. I do not cross the axis there. You might want to put an X, some notation. And then what happens at the other points? I will cross. Okay, so at -1, I will cross the axis, and at -2, I will cross the axis. So you might want to do like a circle and an X or some kind of notation, because it gets confusing after you've graphed them. So I know I cross at these 2 points, and I do not cross at the other one. How do I find the y-intercept? Set x equal to 0. So to find the y-intercept is going to be negative of -1 squared times 1 times 2. What's -1 squared? 1 times 1 is 1 times 2 is 2 with a negative in front of it. This is 0, -2. That is the y-intercept. So it's -1 squared is 1 times 2 with a negative. So 0, -2 is the y-intercept. Now, where does this graph start? On the left. Am I up or down? I'm down. Okay, so then before I do it, is it possible to go up through this point? I got to cross, hit this point. Here I cannot cross, which means I have to go back down here. Is that where I wanted to be? Yeah, that's where I wanted to be. So this is all going to look out good for us. So we start down, we cross, and we do not cross at that one. And that's what this graph looks like. So that's what makes them a little more complicated, this multiplicity and not crossing. Okay. Now, what would happen if you didn't catch this thing right here across? What would happen if you made it go up? It would. Yeah, it wouldn't be behaving like an even function. So you got to when you're graphing these and the graph's not working out, go back and check. Did I get the degree right? Did I get the leading coefficient right? Another common thing that people will do is, suppose in the course of graphing this, you thought that the y-intercept was up here, okay? You would come here, here, and then you'd have a problem. You'd be like, well, how do I get back up there? You can't make the graph circle back around or anything fancy like that. If the y-intercept is causing you a problem, then what do you think you need to do? Go check it, okay? Because if you put the y-intercept up here, this graph is not going to work out, okay? Because it would need to cross again, or it would need to bounce here, okay? So that's just sort of a helpful hint. So there's a lot of stuff that's getting put together, guys, into graphing this. Each individual piece is probably not that hard, but it's a lot when it gets put together, okay? Now, I say all that to say we're going to put one other thing on it here. What if my goal is to graph this guy? So if my goal is to graph this guy, every other thing that I showed you before started out in what form? This is what? What form is it? Starts with an F. It's this factored form, okay? I'm asking you now to graph something that is not factored. What do I think you need to do then? If it's not factored and you want it to be factored to graph it, what do you have to do? You got to factor it. So how can I factor something like this, which has x plus 1 as a factor? Yes, synthetic division. So I'm going to set this up -1, and I'm going to write, I've got to have an x cubed, an x squared, an x, and a constant. So what numbers go here? This is 1, 0, -7, -6. Okay, if I bring the 1 down, 1 times -1, add to get -1. -1 times -1, add to get -6. -1 times -6, add to get 0. So this tells me that x plus 1 is a factor. It should be because I told you that it was, okay? So now this polynomial, f of x, is equal to what? What's the factor that I know? X plus 1, that's the factor that I know. And then how do I read this bottom row? This is what? X squared, x constant remainder. How do I read that? X squared minus x minus 6. Okay, I'm on my way to being factor, but I'm not quite there. What do I do next? Yeah, I got to factor the quadratic. So I need two numbers with the magical, mystical properties that they multiply to -6 and they add to -1. You've done this long enough to know those numbers are what? -3 and +2. So what is the factorization of this guy? Well, no, it's x minus 3, x plus 2. So this polynomial is x plus 1, x minus 3, x plus 2. Now I have completely factored this polynomial, and this is the form that I want it in when I go to graph it, okay? So we've spent time doing this so that we can get to graphing. So if I go look at this guy, what did we say? It was f of x equal, what do we have? X plus 1? What was it? X minus 3? X plus 3, x minus 2? Okay, you guys help me. You're trying to throw me a loop here. It's x minus 3, x plus 2? Do I need to go back and check it, or are you guys telling me the truth? Okay, that's it. Okay, now, I've got it to here. What degree is that polynomial? 3. Okay. What is the leading coefficient? 1. Okay. Now, I could find that two different ways. It's easy to look at that and see degree 3, right? Okay. It's a little bit harder to do it over here. It's x times x times x. So when I've got both of these forms next to each other, sometimes certain information is easier in the other place. So it's easy to see that's third degree with the leading coefficient of 1. What does that look like graphically? It's going to look like x cubed, okay? So it's going to go up in this direction and down in this direction. So as I travel to -infinity, where does my graph go? If I go to the left, where does the graph go? It goes down to -infinity. As I go to the right, where does it go? positive infinity. Okay? Now, to find the y-intercept, it's very important. If you've got both forms here, okay, what do you have to put in to get the y-intercept? X equals 0. Where is it easier to substitute x equals 0? In this one or this one? Which one's easier to put in a 0? The left or the right? The left, because if I plug in a 0 here, this is 0 minus 0 minus 6. You see that? If I plug in 0, this is 0 minus 0 minus 6. What's the y-intercept? 0, negative 6. Now, I could do the same thing over here. If I plug in a 0, I've got 1 times negative 3 times positive 2. I still get negative 6. Okay? So having both of these things side by side, there's certain pieces of information that are easier. Now, the x-intercepts. You cannot look at this and tell me the x-intercepts. Where do you have to go to find the x-intercepts? You got to. That's why we factored it. So what are the x-intercepts? Yeah. Yeah, negative 1, 0, 3, 0, and negative 2, 0. Okay. Is there any multiplicity here? No. So that means at each of those points, what will my graph do? Cross the axis at negative 1, at positive 3, and at negative 2. And what's the y-intercept? 0, negative 6. Where does this graph start? Starts down. So is it possible to go down, cross, 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 and then end up going up? Yes. So that is all possible. So this graph does something like this. And that is it. Okay? Feedback on this, guys. It's a lot of stuff that has to pull together, okay? So we were sort of going a little bit slow. We were doing different lessons. Degree, leading coefficient, synthetic division, factoring. All those things come together today when we start to graph this, okay? So here's your procedures. You need to be able to find the degree of a polynomial. You need to find the leading coefficient. You need to know what it means when the degree is even, when the degree is odd, when the leading coefficient is positive or negative. That tells you the end behavior of the graph. When the graph is fully factored, that gives you the x-intercepts, okay? Multiplicity tells you where it crosses or doesn't cross the axis. To find the y-intercept, you set x equal to 0, and then you sketch the graph, okay? That should be it for this lesson, okay?